So I hope you're able to see my screen now. Yes, able to see my screen now?
Yes, sir.
Yes, sir.
Yeah, I was here. I don't know. Manjunath says last 10 minutes my network was not there. Then okay, I
You are
repeated.
not in the meeting only, sir. You are not there in the meeting itself.
ಯಾವಾಗ ಅವಾಗಲಿಂದ
Sir,
ಆಗಿಲ್ವಲ್ಲ ನನಗೆ.
recording also stopped, sir. No one was there, sir. Means only the students were there. We were not there, sir.
Okay. Fine. Where I was. One minute. Still, this is fine, no? I've been covered, and this is also fine. This point I covered, no? How the random access preambles are generated.
Yes, sir.
This I told about. This is actually it is just second slide. Okay, I think I told about this. Then about generation of H-ARQ sequence also I told. Right. So the generation of random access preambles, how they are generated. I said that the random access preambles are generated from the H-ARQ sequences, and the network will configure the set of preamble sequences that the user equipment is allowed to use. Okay. I said in each cell there are 64 available preambles which are generated from the one or other the H-ARQ sequences. Okay. And these H-ARQ sequences have a very good zero cross correlation. But because of that, there will be no intra-cell interference from multiple random access attempts using different preambles in the same cell. Because in the same cell, see, there are several users will be there. They will be trying to access the network simultaneously, right? So because every user equipment will be using the H-ARQ sequence for this, so and they have very good zero cross correlation. With that, there will be no intra-cell interference. Okay. Then I think I told about this transmission of the random access preamble is restricted to certain time and frequency resources, I said, right? So what I said, the physical random access channel resources within the radio frame are indicated by this physical random access channel configuration index that will be given by the higher layers, right? So for frame structure type 1, with the preamble format 0 to 3, there is a maximum of one random access resource per subframe. But for frame structure type 2, it can have multiple random access resources in the uplink subframe that depends on the uplink and downlink configurations. Okay. I think I was discussing about this in the frequency domain. Yes, now I'm in line. Hello?
Yes, sir. Yes, sir. You are there.
Okay. So in the frequency domain, I said that the random access bus occupies a bandwidth corresponding to 6 consecutive resource blocks. I said one resource block will be having how many subcarriers? 12 subcarriers, right? So 12 into 6, which will be equal to 72 subcarriers, right? As I said, the physical random access channel uses different subcarrier spacing than the other physical channels. Okay, with the preamble sequence length NZSC. So what I said, the preamble format 0 to 3 uses the subcarrier spacing of 1.25 kilohertz, and with the H-ARQ sequence length will be of 839. And preamble format 4 uses a subcarrier spacing of 7.5 kilohertz, and with the length of what? H-ARQ sequence length of 139. But usually the subcarrier spacing will be what? 15 kilohertz, right? For data symbols, right? So here we are using 1.25 kilohertz for some preamble format and 7.5 kilohertz for the preamble format 4. So this is done. Why we use this 1.25 kilohertz is to minimize the orthogonality loss in the frequency domain and it is also possible to reuse the IFFT or FFT component. Okay. Right. And then I was talking about this equation, means how the baseband signal generation of physical random access channel is different from other uplink physical channels. Right? So as I said, we are not using DFT based precoding for this PRACH, because the DFT of the Z2 sequence is also a Z2 sequence. Okay, so because of that, no DFT based precoding is used for the PRACH baseband signal generation. And as I said, this is the expression for continuous time random access signal. So which that is S of t is equal to beta into the summation k equal to 0 to number of subcarriers minus 1. Another summation 0 n equal to 0 to number of subcarriers minus 1 x u v of n. I will tell what each term is, and this like this it is there, right? So as I said, beta is an amplitude scaling factor for the is to be, and this psi, okay, is the fixed offset, okay, that will determine the frequency domain location of the random preamble within the physical resource block. Fine, and this capital K is what? Delta F divided by delta F RA. So delta F is the what? Subcarrier spacing for data, and delta F RA is the subcarrier spacing used for random access. So which is 7.5 kilohertz for preamble format 4 and 1.25 kilohertz for other preamble formats, that is from 0 to 3. Right. So this value of K accounts for the difference in subcarrier spacing between the random access preamble and the uplink data transmission. And K naught, I think here I'm using K naught, right? That K naught is equal to this, means number of physical resource blocks for this random access. I said only for format, preamble format 0 to 3, there will be one resource block, random access resource block in one subframe, right? For preamble format 4, we can have multiple random access resources, right? That depends on uplink and downlink configurations, I said, right? So here K0 is equal to number of physical resource blocks in for random access, and number of subcarriers allowed for that resource block minus number of resource blocks in the uplink, number of subcarriers per resource block divided by 2. That will control the random access preamble location in the frequency domain. Okay. And I say the number of physical resource block for this random access will be less than the number of resource blocks in the uplink minus 6, and will be greater than 0. Okay. So that will be decided by, means the ERB number is configured by the higher layers, I said. So this is all about RACH, that is random access channels. So next we'll be discussing about the hybrid ARQ in the uplink. So now I need some inputs from you people. So I already discussed about the hybrid ARQ in the downlink. Okay, are you aware? Remember? I don't know, I'm in the network or not. Yeah, I'm in the network, I feel. Yes, you people should speak now. For the downlink hybrid ARQ procedure, I have already discussed, right? So can anyone say what are the different techniques we used for downlink hybrid ARQ process? Anybody remembered? Hello? Other than Manjunath and Raghav should respond. Hemant, ಹೇಳ್ತೇನೋ ಹೇಮಂತ್ ಇದಾನೋ ಇಲ್ವೋ ಹೇಮಂತ ಇಲ್ಲ ನೋ ರೆಸ್ಪಾನ್ಸ್ ಫ್ರಮ್ ಎನಿಬಡಿ ಎಸ್ ರಶ್ಮಿ ಸುಧನ್ವಾ ಮಂಜುನಾಥ್ ಕೇಳಿಸುತ್ತೇನಾ ಮಂಜುನಾಥ್
Yes, sir. Yes, sir. Audible, sir.
ನಿಮ್ಗೆ ಬೇರೆ ಯಾರು ಮಾತಾಡ್ತಾ ಇಲ್ವಲ್ಲ ನಿಮ್ ಫ್ರೆಂಡ್ಸ್ ಸುಮ್ಮನೆ ಲಾಗಿನ್ ಅನ್ಸುತ್ತೆ
Yes, sir.
ಅಲ್ವಾ ನೋಡಿ ಯಾರು ಮಾತಾಡ್ತಾ ಇಲ್ಲಪ್ಪ ಅಂದ್ರೆ
Yes,
ಇಲ್ಲ
sir.
ಸಾನಿಯಾ ಇಲ್ಲ ಸೊ ನಮ್ಮ ಎಫರ್ಟ್ ವಿಲ್ ಗೋ ವೇಸ್ಟ್ ಅಲ್ಲ ಇಷ್ಟೊಂದೆಲ್ಲ ಎಫರ್ಟ್ ಹಾಕಿ PPT ಮಾಡ್ಕೊಂಡು ಮೇಕಿಂಗ್ ಪೀಪಲ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಯಾರು ಬರ್ದಿದ್ದಾರೆ ಗಗನ್ ಎಸ್ ಲೇಖ್ಯ ಎಸ್ ಗಗನ ಆರ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ವಾಟ್ ಐ ಆಮ್ ಟಾಕಿಂಗ್
Yes, sir. I'm here.
Can you say something about the downlink hybrid ARQ procedure? Remember, now I am going to hybrid ARQ in the uplink. Okay, to understand what is hybrid ARQ in the uplink. So, there would be hybrid ARQ procedure in the downlink, which I thought in the back. Do you have any idea what type of procedures are used, at least in general? No idea? Gana,
Yes, sir.
do you have any idea or not about the downlink hybrid ARQ?
So during
At least you can tell what type of protocols used there. I was talked about some type of protocols. Now, when do we get positive acknowledgement? When do we get negative acknowledgement? I told about 3-4 different types of protocols, and which you have shared in CCN also. I heard about stop and wait protocol, go back to N protocol, selective
yes, sir.
protocol. So those are the things which are used in the hybrid ARQ also. Okay. Fine. Kritika Sharma. Kritika Sharma. No. Bharat Kumar.
ಸರ್
ಏನ ಕೇಳಿಸ್ಕೊಂತದೇನ ಹೇಳೋದು
ಹಾ ಸರ್ ಕೇಳಿಸ್ಕೊತಾ ಇದೀನಿ
ನೆಟ್ವರ್ಕ್ ಕರೆಕ್ಟ್ ಆಗೈತಾ
ಹಾ ಸರ್
ಓಕೆ Okay, as I was telling, this hybrid ARQ, okay, hybrid ARQ retransmission is all used in the uplink, okay, because the ENB has the capability to request the retransmissions of incorrectly received data packets, right? So it is it to know whether the data packets transmitted are received correctly or not, okay, isn't it? That is what the and it will do the detection and as well as correction of the packets if there is any error in that, right? So hybrid ARQ retransmission protocol is also used in the LTE uplink because the ENB has the capability to request retransmissions of incorrectly received data packets. So for the uplink hybrid ARQ process, I said the corresponding positive acknowledgement and negative acknowledgement is carried on this channel, that is a physical hybrid ARQ indicator channel, PHICH. Okay, so LTE uplink applies the synchronous hybrid ARQ protocol. So this is very, very important. In case of downlink hybrid ARQ, it uses asynchronous. Okay, but LTE uplink applies the synchronous hybrid ARQ protocol. So what do you mean by that synchronous hybrid ARQ protocol? The retransmissions are scheduled on the periodic interval. Okay, means the retransmissions maybe for every 4 subframes, it should send the acknowledgement for all those 4 subframes, whether it is positive or negative, like that. So it is synchronous. Okay, but in case of downlink, it was asynchronous. Okay? So the synchronous retransmission is preferred in the uplink because it does not require to explicitly signal the hybrid ARQ process number. So there is less protocol overhead. So because of that, so less protocol overhead means less packet size and it can consume less bandwidth, less power and other things. Okay. So the number of hybrid ARQ processes and the time interval between the transmission and retransmission depends on the type of duplexing mode used and the type of hybrid ARQ operation is used. Okay. I hope it is clear. What you need to carry is LTE also uses the hybrid ARQ retransmission protocol. As I said, the ENB has the capability to request retransmissions of incorrectly received data packets, right? And as I said, it uses the synchronous hybrid ARQ protocol. But downlink hybrid ARQ uses asynchronous hybrid ARQ protocol. In case of synchronous, what happens? The retransmissions are scheduled on the periodic interval, right? So as I said, the number of hybrid ARQ processes and the time interval between the transmission and retransmission depends on what type of duplexing mode is used, whether it is FDD or TDD, and what is the type of hybrid ARQ operation applied. Okay. Fine. So basically, there are 2 types of hybrid ARQ operation in the uplink. One is the normal hybrid ARQ operation. That is a non-subframe bundling operation, I say. Another one is subframe bundling operation. Okay, this subframe bundling operation is also known as TTI bundling. TTI means transmission time interval bundling. Okay, so let us see what is the difference between these two. In normal hybrid ARQ operation, what happens, and what happens in the TTI bundling type. Okay, so for redundancy versions. Means 4 redundancy versions are transmitted over the 4 consecutive uplink subframes in case of TTA bundling. Okay, so I hope you understand that redundancy version means if the packet is received with error, it will be retransmitting the same packet by adding some more bits to that. Okay. So that is a redundant version 1, 2, 3 like that will be there. So it will be sending the 4 redundancy versions, right, consecutively in the uplink subframes. So same as sending 4 hybrid ARQ retransmissions back to back without waiting for the hybrid ARQ positive acknowledgement or negative acknowledgement feedback, right? So when TTA bundling is used, means a transmission time interval bundling is used, the ENB waits for these 4 TTIs to receive, decode the 4 redundancy versions, right? And it will be sending only one hybrid ARQ acknowledgement or negative acknowledgement over the PHICH in the downlink. Means for 4 this hybrid ARQ acknowledgement, negative acknowledgement, only one there will be an acknowledgement sent from the user equipment to the ENB over this physical hybrid ARQ indicator channel. Okay. So similar to the downlink, here also we are using N-channel stop and wait protocol. And already I discussed about this diagram. Just I taken 1 second. See, this is a normal hybrid ARQ. So packet 1A is sent, right? Because it's sent with error. So the receiver will send the negative acknowledgement saying that it has not reached or some error is there. Then again it will send another version of packet by adding some more bits. Still it is getting error. So negative acknowledgement will be sent. So retransmission is done. Then P1C means P1A, P1B and P1C. These are the different versions of the same packet, 1A, 1B, 1C. So when 1C is sent, it will lastly sends the, if it is received without any error, then it will say success, okay, with positive acknowledgement. So this is about the TTI bundling. So in TTI bundling, what I said, see, 4, right, versions, RB means revised version, 0, 1, 2, 3, right? 4 bundles will be sent. For those 4 bundles, only one acknowledgement will be received. Okay? That is what the meaning is. Because so it cannot wait for the acknowledgement in some applications like VoLTE, means voice over LTE, right? It cannot wait for the retransmission of the same packet because it is delay sensitive. That is what the meaning of this. So again, I was telling about the different modes, right? FDD mode and TDD mode. I hope I'm here. Okay. So the FDD mode, okay, in FDD mode, what I said, there are 8 parallel hybrid ARQ processes. Okay. So 4 hybrid ARQ processes for the subframe bundling operation. Okay. So for the FDD mode with normal hybrid ARQ operation, so upon detection of the negative acknowledgement in the subframe N, the user equipment retransmits the corresponding this one physical uplink shared channel in the subframe N plus 4. In the 6th subframe, it will be sending the acknowledgement. User equipment will retransmit the corresponding acknowledgement bit in the USCH in that subframe. That's what the meaning is here. For the FDD mode with the subframe bundling operation, upon detection of the negative acknowledgement in the subframe N minus 5, okay, the user equipment retransmits the corresponding first PUSCH transmission in the bundle in the subframe N plus 4. So actually this requires a little bit understanding about taking subframe numbers, 2 consecutive frames, and saying this is what the data transmitted in the uplink, and acknowledgement will be getting back in that. So I've not taken the diagram. So try to understand, you have to visualize by yourself that. Okay. So the number of hybrid in the TDD mode, what happens? The number of hybrid ARQ process is determined by the uplink downlink configuration, right? So for TDD, uplink downlink configuration, so it supports totally 6, 1 to 6. And the normal hybrid ARQ operation, so upon detection of a negative acknowledgement in the subframe N, the user equipment retransmits in the subframe N plus K. Okay, given that value of K and subframe N is also given in the table. I will show that table. And for configuration 0, see here it is configuration 1 to 6. For configuration 0, the normal hybrid ARQ operation, upon detection of the negative acknowledgement in the subframe N, the user equipment will be retransmitting in subframe N plus 7, or we say N plus K. That depends on the uplink index field in the DCI and the value of N. So that table is, I think, shown here. Yeah. These are the different uplink downlink configuration. That is from 0 to 6. I said from 1 to 6 what, and for 0 is what, right? These are the number of hybrid ARQ processes for normal hybrid ARQ operation it is. And this is the number of hybrid ARQ processes for subframe bundling operation. Okay? So another table will show you that. What is that? I said in TTD, uplink downlink configuration 1 to 6, that is 1 and 6 with subframe bundling. Upon detection of this negative acknowledgement frame in the subframe N minus L, right? I think K and L will tell you the resource element value, right? The user equipment retransmits the corresponding first PUSCH transmission in the bundle in subframe n plus k. Okay, for configuration 0, it will be from n plus k. I think that this table will show you that value. So this is for different values of k. The value of k for TDD configuration from 0 to 6. So 0 to 6 configuration, and this is a subframe number. At 0 to 9 means a total 10 subframes will be there in one frame, right? For subframe 0, and this is if the TDD uplink downlink configuration is 0. So for 0, it will be sending it fourth subframe as the acknowledgement. For 1, it will be sending it sixth. That is what the understanding of this. Okay, because n plus k, right? N plus k. So n is here 0. So 0 plus k value is 4. So 0 plus 4 is 4. Okay. So it takes time to understand this table. It is that. Then another one I set for the value of L, right? So this is the TDD uplink downlink configuration 0, and then I set for 1 and 6, right? And this is the downlink subframe number 0 to 9. So it means for configuration 0 with the subframe n, okay, the acknowledgement will be sent at 9, subframe 9. Okay, for subframe 1, the acknowledgement will be sent at subframe 6. That's what the meaning of this. Okay, so I don't know how much you could understand or grasp this value also. Okay, so this is what my today's this one. So many are not. Yeah, you can chart your USN in the chart box. The 1, 2, 3, 4 friends have charted. What about rest? So with this, I can stop my lecture. If you have any questions to ask, you can ask. Let me see you on next Friday. Okay. Any questions to be asked, we can ask. Let me stop. No questions? Yes, you also do some homework with just as I said, no. Go to